The following problem will be solved in Creo Simulation with 1D beam elements. So if you're a mechanical engineering student who has started a course in solid mechanics and have access to Creo through your university, this video will help you understand beam deflection, shear force, and bending moment diagram. So let's get started. Okay, so let's say you have a part here. You just sketch a line that is going to represent the length of the beam, but not the whole length, just in two parts, because you're going to have two beam elements, and you dimension the beam in millimeters, 2000 and 4000, and you go to simulate, application, simulate, and you go to beams, under refine model, beams, and you just choose this, and beam section or cross-sectional area for the beam, you go to rectangular, and then you choose 200 the cross-section and 300 millimeters, and you press OK. Beam section orientation, you can rotate it if you want later, but let's look at the plane from the front side. Yeah, I guess it's okay. Now we are going to apply boundary condition to this part, to this point. So home, boundary condition, you choose point, choose this point, and let's let the beam, now it's going to be fixed in rotation, all the rotational and translational degrees of freedom. And then we're going to make a point here to apply a load, a point load. You go to home, force, choose a point, and the direction is minus y direction, and it was 3 kilonewtons, minus 3 kilonewtons, and then you apply another load, which is on the edge, the whole edge, and it's minus 12,000 Newton. We have the boundary condition, and the load and the material will be applied ferrous, high strength, low alloy with the Young's modulus of 210 gigapascal. Apply the material. Now if you go to mesh, you can see that if you create a mesh, you only have two beam elements, 1 and 2. So you go to analysis, create a new static analysis, beam deflection. It's a non-linear, it's a linear problem, multipath adaptive, and you run it. It's going to be so quick because it's only 1D, 2 beams, and the results under display type, you go to graphs, and you choose shear and moment, and we want in Newton meters, and the MZ and Y, the shear forces in the Y direction, and you need to choose where you want this. You press OK, and do you want this to start from here, the diagram, and it's okay, I want to start from here. And yeah, this is the coordinate system. Okay, so this is how the shear force and bending moment diagram looks like. Yeah, so this point is minus 48 kilonewtons. So the maximum bending moment is this much, and the maximum shear force is 15,000. So if you compare this to the analytical solution, we have the same here. The maximum bending moment is 48 kilonewton meters, and the maximum shear force is 15 kilonewtons. Yes, and if you continue to deflection, you can just choose the displacement here in millimeters, and you can see with the graph it's somewhere around 450 something, 450. And if you just want to see the deflection with colors and simulation, and you go with deformed, let it be deformed 5% scaling, and show the loads and constraints, maybe not animated. From the front view, you can see the maximum deflection is 4.62 something. And if you compare this to the analytical solution, which was solved with superposition principle, you can see it's somewhere around 4.61 millimeters. So you can see the analytical solution and the simulation aligns well. So yeah, don't forget to like and subscribe if you learned something, and see you later.